Snap open a colored pencil and look at the core. There is not a speck of graphite inside it, and here is the stranger part. The color is not really in there either. This is how colored pencils are made and how the colors get inside. If you love interesting facts, this one bends your eyes. So where does all that color truly come from? A normal pencil hides gray graphite and clay. A colored pencil is a completely different creature. Its core is mostly wax with a little oil. Packed into that wax is a load of fine pigment. Add a bit of filler and a binder to hold it. That soft, waxy mix is why colors glide on so smooth. It behaves more like a crayon than a writing tool. There is no gritty mineral in there at all. Here is where the two pencils split apart. A gray core is fired in a kiln like pottery. It bakes near the heat of glowing lava. Try that with a colored core, and it would burst into flame. The wax and oil inside would simply burn away, so colored cores are never fired at all. They are gently dried and hardened instead. Fire makes one pencil and would destroy the other. So how do you shape a core you cannot bake? You squeeze it like colored toothpaste. The soft paste is pushed through a tiny round hole. Out comes an endless thread of color, like spaghetti. Blades chop that thread into pencil-length rods. The rods dry until they are firm enough to hold. No two colors are ever piped through the same nozzle. Your bright core was once squeezed through a die. The wood around it copies the classic trick. Two flat slats get narrow grooves cut into them. The colored rods drop into the channels in a row. Glue seals a second slat on top of the first. That wooden sandwich is sliced into many pencils at once. No hole is ever drilled straight through. The color was trapped between two boards. Something keeps nagging at me while I write this. This same box of colors is being made all over the world. A famous workshop in southern Germany, a busy plant in Japan, a big factory somewhere in China. I am honestly curious which country you are coloring from today. The country, not the city. And wherever that is, the color in your hand is playing a trick, because the pigment is not doing what you think. So what is a pigment, really? Picture a powder ground, almost impossibly fine. Each speck is far too small to see alone. White light pours down onto that powder from above. The pigment swallows some colors and spits others back. The light it throws back is the color you see. Change the powder, and you change which colors escape. A pigment does not make color, it sorts it. So think hard about a plain red pencil. Its light reaches your eye, and you see red. Is the pigment sending you red or throwing red away? One word. Reflecting or absorbing? Write it below. Start with the simplest color of all, plain white. That white comes from a mineral called titanium dioxide. It is one of the whitest substances on Earth. The same powder brightens your toothpaste and your sunscreen. It sits in wall paint and even some candy shells. Without it, pale colors would look thin and see-through. A colored pencil shares its white with your bathroom shelf. One powder hiding in 100 places. Now reach for a deep, rich blue. That color once carried a shocking price. The best blue came from a stone called lapis lazuli. Miners dug it from a few valleys in Afghanistan. Ground into powder, it cost more than pure gold. Painters once saved it only for a king or a saint. A blue pencil holds a color that emptied fortunes. Another famous blue was born by pure accident. A color maker was trying to brew a batch of red. His mix was fouled by tainted material by mistake. Instead of red, the pot turned a deep, stunning blue. That blunder became one of the first lab-made pigments. It spread into art and dye around the world. A mistake quietly colored the next 2 centuries. Some of the brightest colors ever made were quiet killers. One vivid green was loaded with arsenic. It glowed on wallpaper, dresses, and painted toys. Whole rooms slowly sickened the people living in them. A fiery red hid poisonous mercury inside it. Even a favorite white was heavy with lead. Beauty and poison once shared the very same jar. Not every color came from rock or a lab. One prized red was squeezed from tiny insects. They were dried and crushed into a deep crimson powder. It took a swarm to color even a small batch. That same insect red still tints lipstick and food. Your grandmother's sweets may have been dyed with bugs. Some color has always come alive. Coloring is not just scribbling with wax. Press hard and layer one color over another. The wax begins to blend and melt together. The paper grain fills in and starts to shine. The harder you push, the more it turns to paint. A rough sketch becomes something smooth and glowing. The little pencil quietly becomes a brush. Not every bright color is built to last. Some cheap pigments fade fast in the sun. A drawing can lose its life in a bright window. Better pigments cling to their color for a century. That is why artists hunt for light, fast pencils. The same picture can vanish or survive on that one choice. But the deepest secret is not in the pencil at all. Here is the twist that flips everything around. A red pencil is not truly red. Its pigment grabs and keeps almost every color of light. The one color it refuses is the red it bounces back. So you are seeing the light it did not want. Every shade in the box is really a reject. The color you love is the color it threw away. And the color does not even finish inside the pencil. It finishes deep inside your eye. You carry only 3 kinds of color sensor in there. Those few cells catch the returning light. Your brain blends their signals into every hue you know. The whole rainbow box is a trick on a tiny handful of receptors. Color is painted in your head, not on the page. So look at that little wooden stick once more. Wax and oil, packed with powdered pigment. Squeezed through a nozzle, never touched by fire. Cased in wood, then sliced into colors. Holding minerals, poisons, and crushed insects from history. And all of it just to bounce light into a few tiny cells. A pencil to faints inside your eyes. I still cannot get my head around one of these. That the color you see is the one shade the pencil refused to keep. Which fact surprised you the most?